Hey guys, welcome to our vocab video for Target 1B. Target 1B is all about similarity, using similarity to solve problems. We talked a little bit about similarity when we were dilating, right? Similarity has the same shape, but not necessarily the same size. And we can use this to help us solve problems. So looking at ratio, right, looking at our vocabulary, the first thing is a ratio. So a ratio is a comparison of two quantities by division. This is important. This is like our scale factor, right? Our scale factor was a ratio, right? And we can write it in a number of ways. You can write it as a fraction, right? Remember, a fraction bar means division. So that's A over B. Or A with a colon B, and it's pronounced A to B. Or just writing A to B. Those are all the ways to really write a ratio. The one we're going to use most, pretty much exclusively, is the fraction. All right. So it's comparing those two quantities. It's saying this to this, okay? Just like our scale factor was comparing. We can also write an extended ratio, which compares three or more quantities. For example, A to B to C, which can be broken down to smaller ratios like A to B, B to C, and A to C. Right? Because if I'm comparing A to B to C, right, I can just take any two of those. I have A and B, B and C, right? Or I can just look at A to C. So for example, extended ratio would be like our class, right? Let's say we wanted to compare the number of female students to male students to teachers, right? So there's 13 female students, right? There's 12 male students and there's one teacher. So you could say 13 to 12 to 1. That's your extended ratio. I can also break that down if I just wanted to know the amount of female students to male students. That's 13 to 12, right? Or there's 12 to 1 or 13 to 1, right? You can break that ratio down. When we write ratios, and to solve using those, we really need to write proportions. Proportions is saying that two ratios are equal, right? For example, 2 to 3 is equal to 4 to 6. I'm going to write that with fractions. 2/3 equals 4/6, which is true, right? If we reduce 4/6, it is 2/3. Proportions is really what we use in similarity problems, because think about what we did with triangles, right? I have all the different sides of the triangles. If it's similar, they have the same shape, meaning they're proportional, right? Everything, all those scale factors are the same, okay? So I can set two sides, right? If I have one side of a triangle equal to the other side of the triangle, that's a proportion, because those should be the same. The last thing we're going to look at is kind of a theorem, altitude to the hypotenuse theorem. And the altitude to the hypotenuse of a right theorem states, right? This theorem states if I have an altitude, and remember an altitude is this line here, it creates that right angle to this, right? So if I go from the 90-degree angle and create a right angle with that hypotenuse, that's your altitude. So the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. So, right, I have my, this line is dividing this triangle into two more triangles. So I have my original triangle ACB, right, that's my first one. This triangle is similar to one of my little triangle here, ABC, and it is also similar to this other little triangle, CDB, okay? All three of those triangles are similar because of this theorem. So if you split like that, you automatically know those triangles are similar. That's it for our vocab for this week. Thanks for watching.